a retrospective study. Retrospective looks back in time and comes across time. Cross-sectional, 1 point in time. Now, what's the difference? Well, let's say I went back and looked at the drunk driving deaths from 1970 to 2000. That's retrospective because I'm going along a timeline versus what was the drunk driving records back in 2020. I mean, 2020. That's a certain point in time. I'm going to let you take a minute and look at that. I'm really not cross-sectional versus retro. I want you to know those. But as far as case control and cohort, just write those down right quick and do a layman's term. These studies are retrospective, meaning that they require individuals to look back in time or require the researcher to look at existing records. In case control studies, individuals who have certain characteristics are matched with those that do not. Case control would be retrospective with cross-sectional. That's basically what that is. But you don't have to do that for my test. You might write that down for later if you take more probability and statistics courses. Cohort means that you're combining. Identifies a group, individuals participate in the study. It's usually a group. Make sure you put a group that's combined. The cohort is then observed. Okay, so a cohort is a group study where you study a group. So I would put study a group on cohort. And usually they are prospective, which means that they will predict something. So the only thing I want you to get from this slide is cross-sectional studies versus retro studies, retrospective studies. Retrospective is over a span of time in the past. Cross-sectional is a certain point in time. Okay. And I'm not going to go through all of these because I'm not going to test you a whole lot on those. So we're going to kind of skip through these. Make sure you know what a census is. I'm not going to spend a lot of time on census because I know in 12 years of high school or 12 years of school, you know what a census is. Census comes from the word centus, which means 100. And I don't know why they do it every 10 years, but you know, it means 100 census. That means 100, but we're not going to get into that. So it's every 10 years. And we've already talked about random sample. Somebody tell me if we talked about random sample. I think we did. Yes or no?
No, I don't think so.
Okay. Random sample, and I'm going to go through this. Random sample is the process where everybody, and write this down and highlight it because I will test you on this. Random sample is when everybody has equal chance. Write that down. Everyone has equal chance of being picked. Everyone has equal chance of being picked. So what does that mean? That means that I write down each one of your, I write down every one of your names on a Post-it note, and then I put it in a fishbowl. So write down fishbowl, names in a fishbowl, or names in a hat. That is an example of a random sample. So write that down because I will test you on that, and you will be test on a standardized test. You will be asked what a random sample is. A computer going through everybody's name in the phone book and picking somebody. that is a random sample because all the names in the phone book are in there and they have an equal chance of being picked. Okay. A simple random sample is a group. All right. Let's say that I call Miss Reed Maroney. I'm just going to say last names because some of these first names are killing me. Maroney Yarborough, and I call them Group A, and I put Group A on a Post-it note and put it in the fishbowl. And then Hill, Fry, and Gravina, I call them Group B, and I put Group B on a Post-it note, fold it, and put it in the fishbowl. Poor, Owens, and King, I call them Group C, and I put Group C on a Post-it note and put it in the fishbowl. And then Glenn, Kennard, and Harley, I call them Group D and put Group D on a Post-it note, put it in the fishbowl. And then I put Moon, Johnson, Anderson, and Butcher. I put Group E, as in Echo, on a Post-it note and put it in the fishbowl. Does everybody have equal chance of being picked? Yes. The only difference is they're set in groups now in the fishbowl. Okay, so for simple random sample, you need to put grouping random sample. The only difference is random sample is individual. Simple random sample is usually in a group. Some books consider them the same. In other words, my 103 book, the 103 book that I teach, it treats them the same. It says simple random sample and random sample is the same thing. Technically, could you say they're the same thing? Do I have everybody in the class have equal chance of being picked? Yes or no? With a group? Yes. Everybody has the same chance. All right. So that's why a lot of books consider random sample and simple random sample the same thing. This book is saying it's a little bit different. Okay. Stratified. Stratified is when you put a group inside a group. Let's say I take this group of people, the 16 that's in the class, and I group you up, one group, and then I divide that group into male and female and do my other classes that way. So I've got 6 groups with 2 subgroups in each. That's called stratified. I'm not going to test you on these as much as I test you on random sample. Systematic. Let's say I go through, I'm going to show you what I'm doing here. Let's say I go through and I pick every third person in the class. 1, 2, Yarborough. 1, 2, Gravina. 1, 2, King. 1, 2, Harley. 1, 2, Anderson. Anderson, did you just come in? I didn't see her name a while ago. Okay.
No, I've been on here.
Okay, I just didn't see your name. I'm sorry. So I went through and I picked every third person. Usually you do this when you're going to ask a survey or something. It is used a good bit. Systematic. Systematic is called, systematic because there's a pattern. Every nth person is picked. Write that down. Every nth individual is picked or asked or surveyed or polled or whatever. Systematic. Every nth person. Cluster is just a plain group. Like my 6 classes, I could treat each one of them as a group. The difference between stratified and cluster is stratified is usually a group within a group, and cluster is just a group. Usually they give graphic examples on these, but okay, strata. Make sure you write down strata. Non-overlapping groups. Each group is called a strata. So the first strata would be my classes. Second strata would be male and female. Within. Okay. Systematic, every nth person or individual from population. Every nth. I already told you that. And we're going to move on to, okay, write this down because this is one of your homework questions. Write this down right here. I don't remember seeing this in the book, but you need to write this formula down right here because they ask you this in the homework, and I've never seen the question before. It was sent to me a couple of days ago, and I'm going to go over it, but I'm waiting until we get at least chapter 2. All right, so write that formula down. P, comma, P plus K, comma, P plus 2K, comma, dot, 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 and then P plus N minus 1, and we're going to do this one right now. I'm going to give you an example. Well, they're probably going to give us an example afterwards, but write that formula down, and also write K is equal to big N over little n. So write that down, and then we also need to write down P. I'm going to write all this down on one of my sheets so you'll see how it needs to be written. So K is equal to big N over little n. And the randomly selected number is equal to P. And then we have P, comma, P plus K, comma, P plus 2K, comma, and P plus N minus 1 times K. And you might want to get your calculators out because they'll probably give us a example on the next page. And they don't. It's very nice of them, isn't it? Okay, they don't. And here's an example. I'm not going to spend a lot of time on this. A simple random sample, stratified within a group, every nth person, and a cluster sample. I find that graphic can be confusing, so I just kind of show it to you. It's in your book, and you can look it up in there. Convenient sample, most least used and least accurate. Now I'm going to give you an example of a convenient sample. Let's say that I work at an 80s rock radio station, and I'm a DJ from 5 o'clock in the afternoon until 3 o'clock in the morning. Okay, or 8-hour shift, whatever, and I play nothing but 80s rock. Next to the 50s and 60s, I think the 80s rock was the best rock. Next to the 50s and 60s. Okay, I don't think we've had good rock afterwards. But anyway, to me, that was the best rock. So I play that 8 hours. And I've got a project. I also go to the local college, and I'm in a statistics class. And I need to do a project for my statistics class. So I ask my listeners to call in and let me know what's their favorite music. What's wrong with this? That means I want y'all to interact. I want y'all to talk.
Only a certain type of people are going to be willing to call in and answer.
Who's going to call? What are they going to like? Good job, Mr. King. What are they going to like?
The same.
What kind of music are they listening to?
The same music that you're sampling, the 80s rock.
Exactly. The same music that I'm playing. In other words, everybody that listens to my station, 80s rock, is going to call in. They're not going to say classical. They're going to say 80s rock. Now, why is this convenient? Because I have thousands of listeners. It's convenient. Why is it inaccurate? Because I asked the wrong question. I should have asked some kind of question like, what did you eat for breakfast? Because it has nothing to do with my radio station. So that's why convenient samples can sometimes be inaccurate. Be careful with convenient sample. You might be asked that on the test. Random sample, simple random sample, systematic random sample, and convenient sample. Those are the ones that usually are asked on a test. All right? Well, I'm going to go back. Well, we'll finish 1.4, and then I'll do this problem. I want to get to, that's it. You only go to 1.4, right? Somebody help me out. Somebody look in the outline. Do we go to 1.5? I don't think we do.
It says we do on the outline.
Oh, it does? All right, bias. That's a strong word right there. Can somebody give me a layman's definition of bias? You know, we could put a man on the moon and we could put rovers on Mars. Why can't we find a toothpaste that goes with fruit juice? Oh, it's awful. It's like a chemical reaction in your mouth of fluoride and acid. Anyway, somebody give me a definition of bias. That means I want y'all to interact.
Being in favor of something.
Leaning to one side. Leaning to one side. Is that good or bad? It is very, very bad. You know, we got on this discussion yesterday in the 120-23 class, and I had a couple of students tell me horror stories of teachers that are biased in one direction or the other, trying to, he said he had an English teacher last semester that didn't even teach English. Every day he would come in and talk about his beliefs and his political beliefs. And that's bad. That's very bad. If you have a teacher like that, you need to get the hell out, or you need to report them to the, and I told them the chain of command. You need to report them to the department head. Then you need to start with the department head. And then you need to go to the dean. And then you need to go to the vice president and the president. And if they don't listen to you, then you need to go to the media and say, this is not right. I don't care which way. You are not supposed to have a teacher that tells you you're wrong for the way that you believe or the way that you feel. Okay? You don't put up with that. I don't care which direction it is. Now, I joke about stuff, but I don't sit there and tell, I'm going to pick on Miss Reed or Miss Poor or Mr. King. You're wrong because you believe this way. That's censorship. And that's infringing on your First Amendment right. And it's getting real bad in academia. And I couldn't believe some of the stuff I heard from this person yesterday. It was awful. Anybody ever had anything like that? Well, good. Please, if you do, get out, because it ain't going to be, especially if you don't believe the same way that person does, that teacher, because it's going to be a long road to hoe. Bias is when you lean a certain direction in a neutral setting. Statistics, people that deal with statistics should be like a referee and a judge. They should be right down the middle. I sit on a land use board, and we vote on things that come up before us, like a committee. And one thing came in front of us one time, and it was a guy trying to use a piece of property that was below 3/4 of an acre. And by county specs, in order to have a septic tank, you need to have more 3/4 of an acre or more. So he was asking for a variance to put a septic tank in on less than 3/4 of an acre. I think it was like 0.66. And it was supposed to be at least 0.75 of an acre. And we had a public hearing on it because it was a variance, and some of y'all may know what I'm talking about, some of you may not. And there was about 15 people in there that was his neighbor, and all they said was, he's going to put a mobile home, he's going to put a trailer on it, he's going to put a mobile home on it, he's going to put a trailer on it. And little did they know that I lived in a trailer for 10 years before I built my house. But there's nothing wrong with a trailer or a mobile home. But I made a point to say before we voted, I said, whether this man puts a mobile home or a house on it or a strip club, I said, that's not for us to decide. I said, that's that man's piece of property. He can put a chicken coop on it for all we care. We are not here to judge him for what he puts on the property. We're here to see if it's legal for him to put a septic tank on the property. And we voted him down because that would have set a precedent. And now, why am I telling you this story? There are some times when you have to be neutral. I don't care what profession you're in. You have to be neutral. You can't lean to one side or the other, especially in a public forum. And being in the classroom, that's a public forum. Or being a referee or a judge or a statistician. If you are doing a research project, and that research project is going to be presented to someone or somebody or some body, meaning like a business, or you have to be neutral. If you're not neutral and you don't put out neutral questions, it's going to kill the research part of your study. It's going to kill it. And it's not truthful. Whether you're a news reporter or a teacher or a statistician or a referee, it's lying, basically, because you're not presenting the truth. You're presenting what you want the person to believe. Now, I will test you on that word bias because I think it's very, very important that you understand bias. I think it's important that you understand the magnitude of bias, because you can't do statistics if you don't understand neutrality versus bias. Okay? Anybody got any comments on bias? Yeah, you're not going to talk to me. Y'all hate me. That's okay. You could have, let's see, sampling bias. I'm only going to pick females for my research. Well, that's okay if you're going to research a female subject, okay? But what if your subject is, for both genders? Then you shouldn't pick all females. If you wanted to pick what is the favorite car or truck for a female to buy, and you're working for the Ford dealership down there on Clemson Boulevard, then you would ask females. But what is the best car for anybody to buy? You wouldn't ask all females. That's sampling bias. Non-response bias. Non-response bias says, okay, these people didn't respond to our survey, so we'll just put them down for voting for Mr. Smith. That's not right. That's That's just not right. And response bias. In other words, this person responded, but I don't like the way they responded, so we're going to put them down for this. And I think with the last current events here we've had in the last year, I think bias is really an important word. That's all I'm going to say, because it's been in the news. Okay? Sampling bias, I done went and told you that. Okay? Except I said female. Non-response. Now, response bias. Go ahead and write down response bias and write down these examples, because these are the ones that you're going to see a lot. Interviewer error, misrepresented answers, wording of questions. That's the biggest one. Number 3, highlight number 3, because that's the biggest one. You're not going to vote for Mr. Smith, are you? Yes or no? That's the leading question. You can't lead questions in a survey negatively or positively. They have to be neutral. So write down response bias as the biggest one. And then under response bias, I want you to highlight wording of questions, because that's your biggest problem. Okay? Give you a second to write that down. Oh, takes at least half your drink to get the fluoride out. Figured that vodka would cut it, but I guess not. I guess I didn't mix it strong enough. Okay. So next. Data entry error. I'm not going to sit here and explain data entry error to you, because that's just operator error. Instead of typing in 54, you type in 45. I mean, that's data, that's human error right here. This is, okay, so I'm going to go ahead and put this as a test question, but I'm not going to explain data entry error to you, because I think most of y'all are pretty smart people and you know what that means. In fact, they give you, for example, 39 may be entered instead of 93. That's called transposing the numbers. So you have to check your data when you put it in. Data entry, human error. I'm not going to get into this. I'm not going to test you on sampling error. So we're going to move on. That's it. Now I think we go to chapter 2. Somebody look and see. 2.1, 2.2, and 2.3. Somebody check me, please.
Yes, sir.
Okay. Chapter 2. Oh, right quick. Here's the question that I wanted to show you before we move on. They will ask you a question, and the question will be, you have 4,000 surveys, and the surveys or whatever, and I'm trying to think of a good number. 75 are returned or whatever. And what happens if you want to start a group with 19. I can't remember the question exactly, but they're going to give you 3 numbers. All right, this is big N, and this is little n. This is going to be part question A. This is going to be question B, or part B, I'm sorry. And that's going to be P. And now you just plug and chug. Now, the reason I'm showing you this problem is this is the first semester I've seen this problem. So I actually had to do some research, to figure out what it was asking. And I didn't see it in the book. I looked, I may be wrong. If anybody has seen this right here in the book, please tell me what page it's on. It must be at the bottom of a page or something, because sometimes you're limited on the ebook from seeing the bottom of the page. So I might have missed it. But that's the formula. So P is 19. And P plus K, well, we got to find K. So K is equal to 4,000 divided by 75. So I'm going to take my handy dandy calculator on my phone. And I'm going to make sure it's a whole number. So 4,000 divided by 75. And that's 53.3, so I'm just going to say 53. So that's K. So P plus K is 53 plus 19, 72. P plus 2K is 19 plus 106. So 19 plus 106. That's 125. Dot, dot, dot. Now, n minus 1. N is 75. So that's going to be 75 minus 1 is 74. 74 times 53. 74 times 53. That's equal to 3922 plus 19 is 3941. And that is your answer to B. And A is right here. So make a note of this. When you see the question that's on 1.4, make sure you make that note. And that's how you do that question. And you'll see it because somebody's going to send it in the homework. Somebody's going to send it. And I do have questions sent. The reason I'm not going over them is because I haven't got to chapter 2 yet. And some of the questions are from chapter 2. So when I finish with 2.3, then the next meeting, which I'm going to try to finish, I'm going to try to get through to as much as chapter 2 as I can today. But that's how you do that problem. So we'll probably be going over homework questions next week or by the end of this week, which will be Thursday. Probably go over some homework questions Thursday. Any questions on plug and chug? Remember, these are going to be given. Big N is going to be your biggest number. Little n is going to be in the middle. And then part B, they're going to give you a number right there, and that's P. Okay? All right. So that helps you on that. Chapter 2. Frequency distributions. That's what we're going to be studying in this class, or this section. Why is this? Oh, I'm way off. Frequency distributions. Where are they? There we go. What is a frequency distribution? A frequency distribution is a 25-cent word for a table. Write that down. A frequency distribution is a 25-cent word for a table. And yeah, you got to talk sophisticated. Now, some of the words that they give you in statistics is just recycled sophisticated words for words that you learned in high school. Okay? They just sound more sophisticated in college. Here are two frequency distributions. And I'm drawing two for a reason. On this side, we're going to say category and head count. And over here, we're going to do classes and head count. Now your table is going to be one of these two. And over here, we got blondes, brunettes, and redheads. 8, 12, 2. And over here, we've got 20 to 24, 25 to 29, 30 to 34, and 35 to 39. 5, 6, 7, 2. Now, first of all, let's talk about what kind of frequency distribution or what kind of tables do we have here? Somebody tell me. And you should know because we've had it before in chapter 1. What type of data or what type of tables do we have here? And this is a test question, so you might want to write it down. Say again?
Stem and leaf or something like that.
No. You're thinking of what you're thinking of is number on the left and dots on the right.
Oh,
that's
yeah.
not what we're doing. Okay, but I'm glad that you remembered that. Think of the data. What kind of data do we have? When I said blondes, brunettes, and redheads, y'all should have thought of something in chapter 1.
Qualitative?
Exactly. This is a qualitative frequency distribution. Why is it qualitative? Because here you have what? Categories, Hubert. Thank you, class. So on this side, we have a qualitative frequency distribution. And over here, we've got a quantitative frequency distribution because it has classes. Or, as they say in this book or another book, bins. I don't use that word because I think it's kind of goofy, so I just say classes. And you can't say head count because that's not sophisticated enough. You know, it's called the frequency. So you can't say head count anymore. You got to say frequency. Everybody got that? Hold your pinky up. You know, like Patrick Star would tell SpongeBob putting on airs. Got to hold your pinky up. Oh, come on. Y'all never watched SpongeBob? That's my favorite. I love Squidward and Plankton. I think Patrick Star should be beaten with a bat. I don't like Patrick at all. And nobody says a word. Really? You're gonna let me talk about SpongeBob and you're not gonna say a word about it. Nobody in here loves SpongeBob.
What
Y'all
was
really
that?
I
suck.
still
Y'all
watch
know that?
SpongeBob.
Okay, go ahead, Miss Glenn. What?
I still watch SpongeBob.
I do too. Me and my kids, my daughter just graduated Clemson in history. We watch SpongeBob whenever we get together. We have to watch at least one good episode of SpongeBob, and I'm talking the first 5 seasons, because after the creator died, it got pretty sucky. But I love the ones where Plankton's in it. I love Plankton. And thank you, I appreciate Miss Glenn for you interacting with me. Thank you.
Okay.
One person out of 15, 16. Rest of y'all suck. All right. Next, what else are we going to talk about? Well, we're going to talk about what is the class width of a quantitative, because we can't really, you can't do anything with this. So I'm going to just take my red pen and I'm just going to kind of draw a dotted X through this. Because technically we can't do anything mathematical with a qualitative frequency distribution. So everything mathematical that I'm fixing to show you is usually with a quantitative frequency distribution. And I'm going to take my pink highlighter and I'm going to highlight these numbers right here. Can anybody tell me what these numbers are called? And I'm going to highlight these on the right, blue. And can anybody tell me what those numbers are called?
Is it lower and upper boundary?
You are somewhat correct. It depends on what book you're reading. So the reason you're probably correct is you might have learned it out of another book. Because if you read this book, it's lower class limits and upper class limits. Okay? So this side, let me get my pink pen. Yes, I do color coordinate. Thank you. This is your lower class limit. And blue is your upper class limit. Okay? This really looks like blue, but it comes out, I don't know if that matches that. I guess it does. But if I try to use blue, if I use royal blue, it almost looks black. So I usually don't use this blue unless I run out of black, and then I use brown and this dark blue. I don't know why I'm telling y'all that. I don't know. I guess I needed to share. Okay, so we've got lower class limits and we got upper class limit. What is the class width? The class width, and write class width down because I didn't. The class width is the first thing you're going to be tested on. Class width is your, I would say, corresponding upper class limit or corresponding lower class limits or upper class limits subtracted. I'll give you some examples. What is 25 minus 20? What is 30 minus 25? What is 35 minus 30? What is 29 minus 24? What is 39 minus 34? All of these equal what? 5. So the class width is 5. 25, 20 from 25, 25 from 30, 30 from 35, 34 from 39, 29 from 34, and 24 from 29. 5. That's how you find your class width. Class width. And you will be asked that on my test as well as standardized test. Can anybody tell me how to find the total that's in the group? How do we find the total? How do we find how many people are in the blondes, brunettes, and redheads? And how many people are in the ages? How many people? What do we do to get the total? That means I want y'all to interact with me. How do we get N, which is the total?
Just add.
Thank you.
Some.
Just add them up. 8 and 2 is 10 plus 12 is 22. I can't get a 10 over here, so we got to have a, let's see, 7, 8, 9, 10. So that's 10, and then 5 and 5, so 20. Check my math. Don't forget N. You got to have N. So right now, what could I test you on? Well, N and the class width. Well, what is the class boundary? Class boundary. If I start with whole numbers, I'm going to go to the tenths. If I start with tenths, I'm going to go to the hundredths. If I start with hundredths, I'm going to go to the thousandths. Everybody get the pattern? So what do I have here? I have whole numbers. So my class boundaries are going to be to the 10th. And usually when you go to the 10th, you go to 0.5. When you go to the 100th, you go to 0.95. And when you go to the 1000th, 0.995. Now you don't have to use these numbers, but that's what's used. So since I'm going to the 10th, my class boundaries are going to be 19.5, add 5. And when you add 5, you get 24.5. Add 5, 29.5, and 34.5. Those are the class boundaries. So I'm going to take my orange highlighter. And since we are whole numbers to the 10th for the class boundaries, here is my class boundaries. Now, what if I had 20.1 here? Then I'd put 19.95 right here. If these were to the tenths, then I would go to the hundredth. If these were to the hundredth, I would go to the thousandth, 0.995, 19.995. And the last thing you want to find with a, well, the last thing you can find without adding another column is the midpoints. And that is your lower class limit plus the upper class limit divided by 2. So in that case, you're going to do 20 plus 24 is 44. Half of 44 is 22 plus 5 is 27. 27 plus 5 is 32. 32 plus 5 is 37. See, the class width not only is part of the test, but your class width will give you the information on these. You just add 5 instead of calculating every single thing. So I just added 5 to 22, or 19.5, and that gave me my next answer. So the midpoint and the class boundary also uses the class width to add to it. Once you find the first one, all you have to do is add 5 to it and keep going. So, without adding another column, you should be able to find n. You should be able to find the class width. You should be able to find the class boundaries. And you should be able to find the midpoint. Midpoints, sorry. Now, I got a question. Did y'all do this in y'all's high school probability and statistics course?
Yes.
Good.
Yeah.
Okay, I always wondered, I don't ask that enough. Okay, so make sure you can find these. What about relative frequency? What is relative frequency? Anybody know? It's another 25-cent word. So I'm going to go to the next page here, and we're going to write our tables again. I'm sorry, frequency distributions. And I'm just going to put the numbers: blonde, brunette, redheads, 8, 12, and 2. And over here, 20 to 24, 25 to 29, 30 to 34, and 35 to 39. 5, 6, 7, and 2. And we know that n is equal to 20 on this one, and n is equal to 22 on this one. Now, what are they going to ask for? They're going to ask for the relative frequency. The relative frequency is a 25-cent word for percent. So you're going to add another column. And I'm going to add another column because I like to confuse y'all, so I do everything in different colors. I'm going to add another column here. And we're going to call it percent. Now, what do you think I'm going to do to get a percentage? Does anybody have any idea, like from a high school probability course? Let's look. Anybody? And I am a Toby Keith fan. It's one of the last country stars I've listened to, because when Toby Keith come along, country started to get stupid. And luckily, Toby Keith didn't go that way with the stupid people. There is no country music anymore. It's country pop. And nobody's going to interact with me. Nobody knows what the relative frequency is.
Some Hank Williams Jr.
There you go, Bo Cephas. You listen to Bo Cephas?
Yes.
Oh my goodness, Miss Glenn. Heck,
That's
my
what we're
son
on.
listens to Bocephus. My son listens to George Strait,
Yes.
King
Good
George.
music.
Yep. And people ask me, why do you listen to George Strait? I say, because a real artist is never dated. And if you think about it, look at the Eagles. The Eagles have been playing since the 70s. AC/DC has been playing since the 60s, no, like 70s. And they are still playing and they are still making music. I mean, you don't date real works of art. I mean, it's not. I mean, I'm sorry. Don't get me started, because some of the crap they play now, I don't even want to talk about. All right. So nobody's going to talk to me, so I'll go ahead and do it. 8 divided by 22. I need somebody to calculate that. 12 divided by 22. And 2 divided by 22. And 5 divided by 20. And 6 divided by 20. 7 divided by 20. And 2 divided by 20. Now, they may ask you to put it in a fraction form, simplified. I'm going to put fraction, decimal, or percent. Fraction, decimal, or percent. That means that the directions could ask you for any form. Please make sure you understand that. And they may say, what is the total? Well, if you do fractions, you're going to get 22 over 22. If you do decimals, you're going to have a total of 1. And if you do percent, you're going to have a total of 100%. Make sure you make that distinction, because there is a homework question that somebody sent me. And the question says, what does the relative frequency equal? Well, the relative frequency is usually, in a lot of cases, written in decimal form. Okay? So therefore, that equals 1. So that homework question, I don't know which one it is, I can't tell you right now, but that homework question is going to ask you, what does the relative frequency equal? And you say, or what is the total of the relative frequency? The answer is 1, because most of the time, probability and statistic books want you to put it in decimal form, the relative frequency. 90% of the time, you're going to put it in decimal form. There may be one question out of 100 that may say, leave it in fraction form or put it in percentage form. 90 to 95% of the time, you're going to put it in decimal form, which means it's going to equal 1. And then there's one more, and that's called cumulative frequency, which is pretty much useless. And I'm going to do this in Yeller. For some of y'all don't know what Yeller is, that's yellow. Yellow. If you're from Pendleton or Belton, people always get me when they move into the area. They call their town, they pronounce it exactly the way it's spelled. And people from around here don't do that. Like Belton, it don't even have a T in it. Okay? But when you talk to somebody that's not from around here, they'll say Belton or Honeypath. We know Honeypath is Honey, Honeypath. You know, not Honeypath. Oh, Powdersville. How many of y'all are from Powdersville? Nobody's going to say anything. That's okay. None of y'all are from anywhere, right? Cumulative frequency. To this day, I have no idea what the cumulative frequency is used for. I don't. I've been teaching statistics for a long time, And I have no idea what it's used for because it's useless. It doesn't give you any type of measure of central tendency. Okay? You start with the first number and you add the second number. And you add the third number. And this number should match up with your total. Now, I want somebody to tell me I don't know what it's for. The only thing I can come up with is that it helps you check to make sure you added the total correctly. Start with the first number, add the second. 18, 20. That's the only thing I can come up with. Question. Now, for a frequency distribution, you should be able to find, and we're going to write this down. Let's do a summary. For a frequency distribution, you should be able to 1, find n. 2, find the class width. 3, after the class width, you should be able to find what? The class boundary. After the class boundary, you should be able to find the midpoint. After the midpoint, you should be able to find the relative frequency. And after the relative frequency, you should be able to find the cumulative frequency. Now, as Mr. King said, you know, a lot of you saw this in probability and statistics in high school. So hopefully this is kind of like a refreshment or, you know, maybe jogging your memory a little bit. Maybe your high school teacher told you what the purpose for the cumulative frequency was, because I have yet to figure it out. We ought to look it up on Google. You know, let's do that. Never thought about doing that before. I guess it really didn't matter by the time class ended. I really didn't care. What is the purpose for the cumulative? I don't know how to spell cumulative frequency. Somebody else has asked it. Now I want y'all to listen to this. Cumulative frequency is used to determine the number of observations that lie above a particular value in a data set. Okay. Maybe I'm going to have to go look for dummies. What is the purpose of cumulative frequency for dummies? Because that makes no sense. So I'll have to research that. Y'all jump on here anytime you want to if y'all have anybody explain what cumulative frequency is. Oh, yeah, right. Y'all not going to talk to me because you hate me. That's all right. I can overcome hate. I'll just put smokestacks on my pickup truck. And that will make me feel good about myself. Right? Oh, you don't do that now, do you? What do you do with your car now? Oh, yeah, you make it lay down in the back, which is really stupid. Almost as stupid as smokestacks on a pickup truck. Anyway, all right, so it's 9:24. We have made it through chapter 2. I need somebody to put 2.1 slide number. Let's see how far we got. Let's see. Here is a frequency distribution. Frequency, relative frequency, bar graph. Okay, we've gotten to 2.1, slide number 12. I need somebody to pretty much put slide number 12 on there. If you don't mind, put that in your notes. All right, you should be able. Okay, I'm not gonna test you. I mean, I'm not gonna. 2.1. Yeah. The rest of 2.1 is bar graphs and pie graphs. I think you can handle the homework. So I think your homework after today, you are responsible for 1.1 through 1.4 and 2.1 homework. Now, what does that mean? What does that mean that you should have done, or that you should have by Thursday when we meet again? You should have completed 1.1 through 1.4 and 2.1 homework, or you should have 3/4 of it done with sending me questions. So if you want to be up with the class and not behind, you need to have this done by Thursday, or you need to have 3/4 of the homework done with the rest of it sent to me because you couldn't do it. Anybody have any questions? Okay, I'm going to turn off the recording and I'm going to turn